Now we are going to use the eigenvalue method for finding a solution for our general solution of this system of linear equations. So first we find the eigenvalues. So what we do is we will just solve this equation, -2, then -1 minus lambda, okay? And that determinant has to equal to 0, which means that we will have 1 minus lambda. Okay, let me just copy paste it here. Okay, times -1 minus lambda plus 2 equals 0, which results in, let's do this here. Factor this negative sign out here. Okay, so becomes 1, and this becomes plus lambda, right? And that is going to give us -1 minus lambda square, okay, plus 2 equals 0, and which actually results in, when we distribute this negative sign, lambda square, and 2 minus 1 is plus 1, equal to 0, and resulting in lambda equals plus or minus I, that is the square root of -1, as the two eigenvalues, right? Now, we are just going to go a little long way and discover something. So when we compute the eigenvectors for lambda equals I, how do we do that? We just take this matrix, right? And if u, v, where not both u and v are zeros, so if that's an eigenvector, then what has to happen is that for that lambda, this quantity has to be 0, right? Or in other words, 0, 0 in R2. Okay, so we got 0 here and 0 here, right? And I'm putting I here and I here as well. So what we get is that we get, let's just write both the equations here. So we get 1 minus I times u, right? Let's put that in parentheses. Okay. So 1 minus I times u, and then plus 1 times v equals 0. And what do we get on the bottom is -2u, okay? And then minus, instead of 1 minus I, what do we get? 1 plus I, and times v equals 0, right? Okay, so what happens here is this, that is, this implies that v equals I minus 1 u, right? So we got I minus 1 u. And let's see, what does the other equation imply? Okay, so here the other equation is this. So when we solve it for v, what does it become is or what it becomes is V equals, okay, 2 divided by 1 plus I, and then it comes down with a negative sign. So we'll have a negative here, then U, and then let's just go ahead and multiply and divide by the conjugate, because we don't want to keep, say we want to get a non-complex quantity in the denominator. So we get 1 minus I and 1 minus I here as well. All right. So this becomes how much? This becomes, sorry. So these two, when you multiply, that will become 1 minus I square. And how much is 1 minus I square? 1 minus I square is simply a 2, right? So that means V equals, the 2's cancel this, or let me write it. I don't know why I am being lazy here. So that becomes a 2, and that 2 will be cancelled by this 2 up here, okay, which will give us, okay, let me write here. So that is going to give us what? So the 2's cancel. So when the 2's cancel, what survives? We get this, right? Which is again I minus 1u. I could have left it like that, but just, okay. So you can see both these rows are are concluding in the same relationship between v and u. So if uv is an eigenvector, okay, all right, what shall we get is that uv equals, I have u here upstairs, and then I minus 1 u on the bottom, right? Okay, so that means if we factor a u out, what we got here is, we got 1 and I minus 1, or rather 1 I minus 1 as an eigenvector, and any multiple of that is going to be an eigenvector. Now, what's going to happen is this, that we are not going to calculate the eigenvectors with respect to negative I, because we need two linearly independent solutions, and you are going to see that this is going to give us the two linearly independent solutions that we want. All right. So now that we have this as an eigenvector of I, what we have is that a solution would be what? E to the power it, right, times this vector or any multiple of it. All right. Now you know this by the Euler's formula, that e to the it is what? E to the it is cosine of t plus I sine of t, okay? And then we got this, and we want two linearly independent solutions. So what will happen when we simplify it? Then it's going to give us two linearly independent real value solutions. All right, so let's see how that works. So we got this, so we will go ahead and multiply them together. Okay, so what do we get upstairs? Upstairs we get simply this, right? And what do we get downstairs when we multiply this in? We get that, right? Okay, so then what this becomes is that we have this quantity here, and what I'm going to do is that I'm going to multiply them together. So when I multiply them together, what will happen? I get I cosine t. Then why am I just talking and not writing? So I got I cosine t plus I square, all right, I square sine t, and then I get minus cosine t, and then minus I sine t, right? Okay, so now let's just do one more little thing. That is, just do simplification here. I square is what? -1, so that's what this simply becomes. And then what you have is that if you want, you can just go ahead and put the terms with i's together and with constants, sorry, with the real and imaginary terms separately. So we got this, and now what we will have is that we got, let's just put this in parentheses, okay, and here I am just going to factor an I out, all right, so we get cosine t minus sine t, and now we are going to split the real and imaginary parts to extract our two solutions, right? So what happens here is that we got this. Let's remove this parentheses, we don't need it. And now we are going to put these out. So we get plus I times, I'm making another bracket, and just be careful. Don't leave in the middle, because otherwise you will be left with an erroneous quantity. And then here on the bottom, I'm pulling this out, and we get this. And since I pulled this out, what you have is this, right? Okay, so what we have now is that, notice this vector here, and this vector, and let me write it, and this, they are linearly independent, okay? All right, are linearly independent, okay? And you can see that both of these are solutions of the given system of differential equations, okay? So what will be what a general solution will look like now? A general solution will look like, you just take C1, right? And I didn't write the short vector form or anything, all right, and we will do that, okay? All right, so we get what do we get? We get simply this, okay? Sorry for the slow speed, C2, and let's just write that as, say, xy, so that's the form of our general solution, all right? So this is the general solution, and C1, C2, they will depend on the initial conditions for a particular solution, all right?